Okay, I think that was the cue that I should get started. All right, welcome to this talk. It's called Solid C++ Code by Example. The idea here is that a lot of the talks about C++ and kind of the guidelines, principles, they start on a slightly too high level in that they assume that the audience already know the small, simple stuff that all C++ programmers should do. And that's what this talk is about. But before I start, I just need to make a small disclaimer, a history. On Monday, I was dragged out to a concert by my wife. It was this brass band concert. I have never been to a brass band concert or ever listened to such music. So, but she enjoyed it, obviously. And I was attending the concert, but the thing was, I couldn't hear the difference between each song. So when I had played the same song 7 times in a row, I thought, well, I can just as well stay outside of the concert area for the rest of the concert. And that is, when you're not into it, you don't see the differences between things. This is a warning about this talk as well. If you haven't been programming C++ for a few weeks, then it might be a bit tricky to see what we're actually talking about. So don't feel bad if you have to leave. It's my fault, not your fault. So just take this small example as an intro. If you don't see more or less immediately a few things to comment on this code, then you might not enjoy this talk. I don't know. The question is this solid code or is it bad code? And I counted yesterday, and within 1 minute or 1 or 2 minutes, I could find 12 issues that I would like to comment on in this code. And I blogged about it 2 years ago. I actually wrote this example. It's called C++ idioms by example. Anyway, the problem when you want to talk about C++ is that nearly all the time the answer is don't use C++. So therefore you can't use this toy examples like this, and you can't use simple examples either, because still the answer would be use another language than C++. So I have, for this talk, I have created kind of semi-realistic constraints, requirements that this library needs to satisfy. And I've also made a module that could possibly fit in somewhere in a code base consisting of a few million lines of code. Indeed, we have exactly such a library at Tandberg, for instance. So what I say, it has to be in C and C++ because it's embedded. It should be convenient to create less than 100 kilobyte clients using this library. And what this library should support is NTLM authentication towards a Windows 2003 Server SP2 version and nothing more. Just enough so that you can do an HTTP GET from that server, authenticate yourself, and then get the values. So I developed that one, this library, just for this talk, and I've published it on GitHub. Feel free to use it or experiment it or do whatever you want with it. And what I've done is I've tried to create this perfect code. And I have consulted a lot of people, probably 50 really good C++ programmers. And they have tried to help me to make this code look really, really, really good. And then I have come up with a few issues, as you can see here, that I have doped the code with. I've changed the code in such a way that it's not perfect anymore. It has all this small badness in there. But even if I've injected all these kind of issues into the code, it does compile. It does compile cleanly. There are no warnings. It does exactly what it's supposed to do. Everything is fine. Most people would say, oh, this is good enough. You can start on another project. What I'm arguing is that if you want to maintain this code over time, then you have to clean things up, and you have to do it properly. And this is what it's all about. So the question is the code kind of, do you see happiness when you see code, or do you see trouble? And the code we are going to look at today really signals trouble. So let's dive into it. We don't need the whole context in order to just look at this example. So take this code example, for example. And do discuss with your neighbor or people around you, and see if 2, 3, 4 of you can come up with at least 1 or 2 things that you would like to comment on this code. Imagine that a junior programmer came into your office and said, what do you think about this code? Please discuss with your neighbor. That's part of the game. Okay. See if we found some issues here. First of all, this class must have a virtual destructor. It's not so that every class in C++ should have a virtual destructor. That's wrong. But these types of classes, they should have virtual destructors for sure. Otherwise, you will have memory leaks. The only way you can use this one is by realizing its interface. And if you don't have virtual destructor here, you will have a few bytes leaking every time you use this one. Another issue, the file is missing a header guard. And since we are using uint8_t, we have to include studint.h. Usually, because the compilers are not behaving correctly, very often the compilers will bring stuff into the name includes through other includes anyway. So usually this will compile, but if you want to make sure that it's portable, and it will compile on future compilers and other compilers, then you must include standard.h here. So here we are trying to fix the code. Add header guards. Oh, I love Keynote. Add a virtual destructor and include the files you need for this header file to compile by itself. And now this is solid code. So let's take a slightly more advanced example. This is the NTLM type 1 message that is deriving from NTLM message that we just saw. So I'll give you another minute or so, and you can see if you can come up with a couple of things that might need attention here. Discuss with your neighbor. Can I have a hands up from somebody that have found something? Just a keyword, just a hint, and I will do the rest. Okay? Yeah, right. Yeah. Yeah, that we want. Yeah. Yeah, yeah. Yeah, good point. And that also leads us into perhaps what should the order be? Yes. Yeah, good point. Any other? Yeah, that's the correct way of doing it in this case. Yeah. Right. Yeah. That's yeah, and we won't go in there. Yeah. Okay. Yeah. Cool. Thanks. Well, this is a simple thing though, but in large code bases, it gets very, very important to know what you include and what not to include, because very often the time it takes to read the source code from disk is fairly large compared to the compile time. And when you inherit something or derive from something, you don't need to include the same stuff over again, because that's implicit, otherwise you couldn't derive from it. So in this case, this include can go away. You should focus on usage. So put public stuff first and then private stuff. And single argument constructors should nearly always have the explicit specifier. It's very, very seldom that you want the constructor to be implicit. This is only a problem when you have a single argument though. So let's try to fix the code. Remove that one. Get a private block as you suggested, and then swap them around. And then, just as a rule of thumb, always write explicit in front of single argument constructors. And if you really, really want implicit, then think again for a couple of times, and then you can remove it. So now it looks good. Now let's see it on the implementation of this typo message. See if we can find something here. Feel free to discuss with your neighbors. Okay, anyone want to see something? You again. You're welcome. Right. Yeah, exactly. You would like to initialize the object properly, because this is not the correct way of initializing an object. Yeah, that's one point. Another one? Yep. That it could be argued, but at the same time, it's some place the complexity needs to go, the concrete stuff needs to go, and this is one place. All right, let's see what we have here. First of all, it seems like the more experience people get with C++, the less they import namespaces like this. And the thing is that it doesn't, doing a using namespace doesn't really increase the readability a lot. It might save you a few keystrokes, but you are reading the code probably much more than 10 times. You spend much more time reading code than writing it. So focus on readability. So this one can go away. And this is not the right way of initializing a C++ object. You have to use the initialize list. And this is questionable. I'm not so sure about this one anymore. But
will you explain why you have to use the initialize list? Only it looks like it's shorter.
For simple objects, it might not make such difference, but as soon as you get more complex objects, you first initialize the object with default values, and then you assign them with... So first you set it to if you have an integer, first you set it to 0, and then you set it to a value, and that doesn't cost very much. That's just one instruction, which will probably be optimized away. But if you have a complex object, then you first set it to the default value of that complex object, and then you assign it the proper values. And who knows what happens in that object. Yeah. Yeah, and you can't initialize const objects, for example, const members, which are also important. So, but anyway, the point with this one is that you should consider using size t whenever appropriate. And appropriate is often when you are dealing with offsets and direct memory access. Then size t and put through diff and stuff like that is the right values to use. It's usually not the right thing to use int or even unsigned or long or whatever.
In this particular case, you already hard-coded the length to being 16 bytes. So
it's arguable. In this case, it's arguable. So yeah.
Personally, I actually prefer to have unsigned for all those things that really should never go negative.
Yes, but on size t, what's important with size t is in the domain I'm working with, we have 16-bit processors, 32-bit processors, 64-bit processors. Some of them DSPs, they have chars that are 16-bit long and things like that. And then you need to know about these things, and especially when you port this code. If you are lucky, the compiler complains. If you're not lucky, then the customer complains. So, okay, let's fix this one. Remove this and introduce stud in front here. And once you get used to it, it reads better. You can replace this one with size t. And you should initialize the object properly. This is the way to do it. All right, let's look at the other message type, also deriving from NTLM message. There are 3 issues here. Using
standard is not inside the plan namespace.
Oh. Okay.
Because otherwise, this inclusion, if you weren't including standard but some custom namespace, then that inclusion would be in the standard namespace.
Yeah. I think, I agree with you, but I think you are just halfway to the solution here.
Our solution might be just remove the heading altogether and inline standard.
Yeah, that's one of the issues. Yeah, come on. Mm-hmm. Oh, there are methods. Okay, let's see. Well, first of all, do not import namespaces in header files. I was not aware of the trick that you mentioned, putting it inside the namespace, but I see that it might work. I'm not sure. But anyway, in the header files, you should not include namespaces, because then you're also polluting all your clients' code. You should consider passing complex objects by const ref instead of by copy. And these methods, they are probably not changing the object, since it's only having const anyway. So that's a very strong indication that these methods should be const. And once you get into a code base where all developers, they add const if you have query methods, and they do not add const if they have modifier methods, then you get used, when you see this code, it kind of screams and say, these two functions, they are going to change the object somehow. So you should always use the const specifiers if you have query methods. So let's fix this. Seriously, do not include namespaces in the headers. That means we have to add the prefix. Use the constref. And add const specifiers to query methods. All right, let's look at the implementation of this one. I can only see one issue here. Yeah. Yes. Yeah. Perfect. You can come up here and join me in the talk. Excellent. Now, yeah, but despite that, this is very common to see in C++ code and also C code that has the same issue. You should always include your own header file first, and then you should probably include your project and platform code, and then the standard libraries. And if you do that consistently, then you make sure that your header files, they can compile by themselves. And the client using the header file is not surprised by, oh, I just need some include files. Yes?
I think that the opposite got in due to precompiled headers. Because Carlos taught you that if you got all the static headers first, then that part could be precompiled and you didn't have to wait for it to go through and recompile. So people got used to putting all the variable stuff, the one I'm working on, at the very end.
Yeah, that sounds plausible. But it's, I'm not sure if that's still an issue, but I can see that it was an issue maybe 10 years ago. So, but 10 years ago, a lot of people thought you needed external include guards as well, so things are changing. So, yeah, this is not a good way of ordering the include files. This is how you should do it. And things like this get more and more and more important as the code base you are working with is growing. Now, have a look at this one. Are there any issues here? I'm sure there are. Yeah, come on, shoot. Yes, you don't need the parentheses around the return statement. There is actually another place where we have extra parentheses that we don't need and we shouldn't use here. Size of is a good hint. Any other thing? Well, let's see. Here we have an example of magic numbers. And when you see magic numbers like this, then you should consider to add explanation or explain variables that explain what you're doing. You don't need these parentheses. And you certainly don't need these. There is actually a good reason for why you should not prefer to have parentheses when you do size of. Because it should hurt to do size of a type. If you take the size of an object, then you don't need the parentheses. You can use the size of operator. And that's what you should prefer to do. So if you have, if you take the size of something, if you can take the size of the object, do that instead of the class or of the type. So remove these. But I can see that some are not so sure, so if you really like parentheses, this is a sliding slope, then maybe you want to add some more. You can even add some up there. So try to get rid of the parentheses if they don't add value. But of course you should use them if they add some value. But they don't add value in return statements or in size-of. So let's first get rid of the magic numbers. We add some constants so that we can replace these magic numbers.
This is a programming style. Would you actually like to keep these constants exactly where you're using them and not up front?
And it depends. It's a very good point. It depends on the code. And in this case, just to make it sure that I fit it on one slide. but it still makes sense. Well, it's a small module in a large project. And you would never...
It's more natural to have files in a project that has all the constants.
Maybe, I see your point. It depends on the size.
If it is the only place you're using that offset,
Yeah,
then it's correct.
it's the only place you're using it. Here. Yeah. Yeah. Actually, that's what's happened on the next type. That's exactly what happens there.
And maybe you have to write this buffer somewhere, then they should be placed together with the right methods to create methods.
Yeah.
The same constant.
Very good points. So we remove the parentheses from the size-of, and we remove it from the return. So now this looks better. Okay, let's take a look at the header file of the last type. Yes. Yeah, there is a strange default value to SSP flags here. Default arguments. Yeah. We completely agree. Yeah? Oh. Which one? Yeah. Yeah, it looks like
It could be initialized
it is.
in the constructor.
Yeah, it is initialized in the constructor, but it's also it's a small, tiny smell of implementing stuff that we don't need here. But this is how a type 3 message is supposed to look like, and the values it's supposed to have. So it makes sense to add them anyway. Shall we take a look at the issues? There is a hint around the constructor there. It has a specifier it doesn't need. Yeah. Why it's... Oh, no, it is actually a reference. So, and you're now entering into what I call the Star Wars. the war between Cunningham and Ritchie. They put it next to the object, and Bjarne Stroustrup, they stuffed the star and the reference next to the type. But after years of fighting, we do actually now have a unified way of doing it that it seems like a lot of leading C++ gurus are using now. They put space on both sides.
It makes these mistakes that we made it not easy.
I agree. It's if you're not used to see it, but most of the books that comes out and articles written about C++ these days, they have this. They are using this style of space on both sides of asterisks and ampersands. All right, let's have a look at the issues. Now, if you can forward declare, then do it. You should always prefer forward declarations. And that's true for IOStream, certainly, but it's also true if you can, for other complex classes you might have. If you don't need to know the size of the object, then you can probably forward declare it instead. Default arguments, they are very often they are not needed. When you see default arguments and you start to search for clients using it, you will very often find that nobody is relying on this default argument. And if you really, really need default, kind of the behavior of default arguments, you should consider to create two constructors instead of using this.
Yeah, probably it's mostly used for backward compatibility. It's very augment resistant.
Yeah, but
It's a clean project, you should use it.
yeah, and yeah, if it's clean project, you should try not to use it. And also, if you're fixing old code, you can also always get away with delegation or with just overloading stuff. So it's not a very strict rule, but and certainly in this case, it's not needed. And you shouldn't just add specifiers because it's nice to add specifiers. And in this case, it's a multi-argument constructor, and it doesn't need explicit specifier. It's only the one argument constructors that need it. So let's fix it. Forward declare, remove this one, get rid of this one. And now the code is not too bad. So, the final file that we are going to look at. This is a couple of the issues here. They are only possible to see if you have photographic memory. I'm sure some of you have it. So.
Well, there's a not equal LM response size, which is probably the private member, and that probably should have an underscore at the back at ender. If this is a member access. You added the session key, wasn't in the constructor, was it?
Yeah.
In the header file, did you have a session key?
Yeah. Well, all this code compiles without any warnings. And it does exactly what it's supposed to do. It's just that it's not. It smells trouble because there are issues here. So there are no compile errors. There is a really, really big what the fuck here. I know I'm not allowed to say that on video, but I'm Norwegian, so I'm allowed. Yeah. It's LM response is a vector, so you can. It's the same as length. But length is. That's part of the magic introduced by, as I said earlier, the constants are not defined locally anymore. They are defined other way. So just assume that it's a constant.
But shouldn't use some kind of. So you never use any kind of typographic methods distinguished it in constant and
Not anymore. As most programmers, I also used to do uppercase for constants and things like that. But it seems like people are moving away from that.
why are you moving away from it?
Because people tell me to do so. I'm working together with 100 other C++ programmers on a daily basis. Yeah. Maybe. Good point. But there is something much, much bigger here. It's really, really big. And it's something that very often the customer finds out, because it's very seldom that you're able to test for this error. And it happens all the time. Has to do with exceptions. All right, let's reveal it. Oh. This is so common to see in C++ code. And it's completely wrong. And the reason why it's still there is because very often you have, you might have test and unit test that checks whether you get an exception, but you don't really check what the exception is. And in this case, we are throwing a pointer and not the exception. And I think the reason why this is, you can see this in C++ code, is that a lot of Java programmers, they try to write C++. And this is the way to do it in Java. So if you knew an exception, then you just get the pointer, and that's not what you want. Yeah, so it's probably easy to use a grep through the code base to find those issues, and we have done that several times, and we find them over and over again.
I was worried about another thing.
Yep.
If you actually instantiate a new object in your exception handler,
yeah.
then you can, if the original exception was due to running out of memory,
Mm-hmm.
then at this point you would really crash.
That's one of the arguments. That's one of the arguments why you shouldn't do it as well. Yeah, good point. Very good point. Yeah, so this is the biggest issue here. And this was the photographic memory I was talking about. One thing I want to say about the previous one, though, this one, is that it's impossible to write compilers and that catches this one. Because it's completely legal C++, and you can put on all the warning flags you have. And you will still not get an error on this one. So it's very difficult to trap this one. Oh, sorry, I clicked the wrong button. So this one doesn't match the initialization order properly. Because members, they are initialized in the order they are written in the header file, in the declaration. And this does not match. Now, this might not be so important in this small case, but it indicates a deeper problem. It indicates that you have with programmers or group of programmers that are not using Wallenvextra because they would tell you. Or even worse, you might have programmers that accept having warnings in their code base, and which is very common, but it's a disaster, really. So add as many raise the warning level as high as possible, and consider to use Verer in your compiler. Treat warnings as errors. That's what we are doing in our code base, and it has saved us loads of time.
I always do that, even if it means that in a few places, like inline assembly, I actually have to override it again to be allowed to do what I'm doing. But then there's a big flag on it saying, okay.
Yeah, it's probably a good idea. And also, it's often a good idea to initialize the whole object explicitly. Even if you know that it's getting the default values, just be explicit about it. And if you add the VEFC, effective C++ warning flag to it, you will get warnings. Yeah. So get rid of those. swap the order, and then initialize, be explicit when you initialize the object. It might save you some debugging time. All right, the final one that we're going to look at. And this is really, really bad. It indicates some deep, deep failure in understanding programming. It's only one thing. I wish I had a prize that I could give to the first one spotting it. Yes. Oh, no, it's much worse than that. It's really, really bad. This stud hex thing. I'm not going to explain it right now, but you're very close to to the place where the badness is. Yeah. You said? Yeah. It's not only the width. You're changing the for example, from decimal to hex. So what happens here, if you have made a function where you kind of try to make someone give you a stream. It might be a file stream or a log stream, or it could be standard out or whatever. And then you get this stream and you do stuff with it. And then you change the behavior of the stream. So when you give it back, from that point, this stream will print every decimal as a hex decimal instead of a decimal. So when you have an error message like 18, then you will see 12 in the log. And of course, that's bad. It's really, really bad. So that's not what you want to do. And it's the way the streams are built up, it's very difficult to solve this problem by saving the state and restoring it later. And there are no easy ways to do that. So usually when you see a function that takes a stream coming in, you should consider whether it's possible to do it another way. And in this particular case, it might make sense to build a local string stream and return it as a string instead.
So you're really saying that this thing would actually work better with a printf?
Yeah. And it's a lot of things that would work better with printf. Yeah, it's not as safe, but it's much more convenient to use. So this might be a solution to the problem. You don't borrow the O stream anymore. You just change the signature and say, I can give you a string that you can do whatever you want with. And from a usage point of view, this is just as easy to work with as giving a string. Two-string? Yeah, instead of debug. Right. Yes. This debug print method can be criticized for many reasons. I added it just to show this point. So then we have kind of looked through some of the issues in the code. There are actually 26 or 25 of them. And I will now run through them as a reminder. First of all, base classes, they should have virtual destructors. What does it mean to be a base class? A class without virtual functions. So that's not the base class. You're not supposed to derive from classes without virtual functions. There are other ways to solve that problem, so you're just misusing a language feature if you do. But if you do have virtual functions in your class, then you have designed it to be derived from. It's a base class, and therefore it should have virtual destructor. Otherwise, you will leak small bits of memory throughout the execution of that program. Header files, they should have include guards. And when you choose a name for the include guard, it's probably a good idea to include the namespace and the full file name, and maybe even an explanation of what this define is doing. So in my case, you saw I added the PAL NTLM message underscore HPP underscore included. It might be too much, but it doesn't hurt. Make sure that your header files, they can compile standalone, so the client doesn't need to add some extra stuff before they can include it. That also might be a reason why people tend to include loads of stuff before they include their own. There's no need to include files that are already included in base class declarations or needed by the base class declaration. Remember that single argument constructors should nearly always be specified as explicit. Focus on the usage of class. Put the public stuff first and then the private stuff. Always focus on readability. Remember that you spend much more time reading code than writing it. Importing a namespace in an implementation file is usually not a good idea. Of course you can do it because it's your file. You don't hurt anyone else. No kittens are killed. But kittens are killed if you do it in the header file. Don't do that. It's serious misbehaving. Remember to initialize objects properly. Use the initializer list as much as you can. That's a proper way of constructing an object. Prefer size T when working with memory indexing offsets, and this is particularly important when you work with memory with the library functions, because otherwise your code is not portable. Prefer pass by const if you are working with non-trivial objects. Query methods, they should be specified as const, and if you do that consistently, it means that if you don't have const, you're shouting to the rest of the world that I am going to modify the object. Here are the way to order the include files. Include your own first, and then the project and platform, and then the standard library. Think about magic numbers. Consider using explanation variables instead. Avoid these parentheses, otherwise you will be a Lisp programmer in the end. Prefer forward declarations when you can. In our code base, for instance, we save minutes, many minutes, by thinking about what to include, when to include the whole header file and when only to do the forward declaration. It can really save the compilation time. And if you can reduce the compilation time from 25 minutes to 20 minutes, it's usually worth it. No need to add extra specifiers. And you should, one of the reasons why 18 is important, because at some point I thought adding explicit for all constructors was a good idea. But then I discussed with Kevlin Henney, and of course he had thought about it. And he also had the reasons for why he preferred not to do it, and that had to do with explainability. Now, if you write code, when you write code and you think, okay, this might be clever, but it would take me a few minutes maybe to explain to another programmer why I'm doing this. That's an example of that is this idiotic idiom of saying that if 42 equals A or something like that. It might be a good idea in your head, but you have to explain people why you are doing it over and over again. And if you focus on this explainability, then you can derive a lot of the principles that you should follow in C++. Don't do things that needs explanations. Too much explanations, at least. Avoid the default arguments. There are other ways of solving it if you really need it, but very often you find that nobody's relying on that default argument anyway. And certainly do not throw pointers to exceptions. Treat warnings like errors. That's an advice. You don't have to do it. But you should certainly try to raise the warning levels so that you get the tool support from the compiler, such as Wall and Vextra. And even, very often I compile with Pedantic. It's helpful, especially when you write new code. It's possible to write it in a way that even the Pedantic flag won't complain. Yeah, that's on 23. And do not mess with borrowed things. And always consider the side effects of what you do. And that's relating to 24. If the client is calling you with standard out and you just change that from now on, everything you print out is in octal, it might take a while before you realize it. It might even be the customer that realizes it. So, that's it. Thank you. Do I have time for questions or? Yeah. So you're free to leave. I encourage people to leave, but if you have some questions, then I take some. No, we can do it offline later.